Imagine holding a few apples. If asked how many you have, the answer is intuitive. You just point and count. 1, 2, 3. We call these natural numbers. They are the original tools of human history, used for thousands of years to keep track of a harvest or a herd. This system starts at 1 and climbs upward forever. 2, 3, 4, and on toward infinity. It is a set built specifically for whole physical objects you can see or touch. By design, this excludes anything partial. Early counting was for what was present. Our ancestors didn't have a mathematical reason to measure half an apple or a quantity that didn't exist. To organize these, let's place them all into this bag. Every positive counting number from 1 to infinity lives here, under the label natural numbers. Mathematics began as this kind of physical inventory system. It was a tangible invention, created to help people manage the real-world resources right in front of them. Eventually, humans hit a wall, the problem of depletion. If you have a basket of apples and eat them all, how do you mathematically describe what's left in that empty space? The invention of the number 0 acted as a massive technological upgrade. It allowed us to move beyond physical objects and start measuring the state of having nothing at all. 0 gets its own space. We create a larger bag to hold it, and our natural numbers bag drops inside. This container, whole numbers, combines 0 with our counting numbers, 0, 1, 2, 3, stretching to the right. Creating this category gave us the ability to prove that an empty field or a finished harvest is a measurable, countable state. As civilization moved toward trade, the ledger became more complicated. Suppose a merchant makes a $200 profit one day and suffers a $200 loss the next. Writing down 200 for both entries creates total ambiguity. Without a new type of symbol, it is impossible to distinguish a successful gain from a devastating deficit. Negative numbers, -1, 2, and 3, were the technology designed to solve this. They gave us a way to track debt and loss with total precision. Now we bring out the largest bag yet, filled with negative numbers. The whole numbers bag fits inside. We'll call this container integers. It's the full set, positives, 0, and negatives, creating a line from negative to positive infinity. Integers allowed humans to track promises and future trade. We could finally balance the books on things we didn't yet own, rather than just the inventory sitting on a shelf. This structure creates a specific logic rule. Every natural number is a whole number, and every whole number is an integer. But that logic doesn't work in reverse. Because these bags are nested like Russian dolls, a number like 2 sits at the very center. It is part of the natural bag, which means it is automatically part of the whole and integer bags surrounding it. However, a number like -2 only lives in the outermost bag. It cannot enter the inner natural bag because counting numbers don't include negatives. Even these categories have limits. If you slice an apple in half, none of our current bags can measure it. We would need to build an even larger layer for fractions and decimals, called rational numbers. This system is a nested toolkit, built layer by layer over centuries. Each new bag adds a capability we didn't have before, allowing us to measure everything from a single apple to a global trade deficit.